Hi guys, I hope you're good since last video. So this time we're gonna be focusing again on Kubernetes and how to access to applications using load balancer. And we're gonna start with the architecture. We're gonna use here MetalLB. In the last video we used the gateway API. So here it's another way also to access to the applications using a load balancer. So MetalLB is Metal Load Balancer. We're going to start maybe with the user, just to understand how it works. So user, try to access to the application through the load balancer. The load balancer behind it has the MetalLB speakers, so daemon sets. The speakers are linked to the MetalLB controller, which is going to be referencing the IP address pool on the L2 advertisement. And the L2 advertisement is going to be giving those services, which are type load balancer, IPs, and having the access to the backend applications. So that's how the users will be able to access to those applications using this strategy. So we have the namespace, MetalLB system. We have node 1, node 2, we have 2 workers. The MetalLB controller is deployed on worker 1. This is from the previous video, I'm just going to get rid of it. So we've seen the architecture. This is Kubernetes as usual, this is the controller, scheduler and everything. So you'll be able to understand what we're doing next, otherwise it will be a bit confusing. So keep this in mind. So we need the config map of kubeproxy to set the strict ARP parameter to true. So ARP is the address route protocol or address resolution protocol. It's for the load balancer to be able to get those addresses, and it's gonna strengthen, so improve the Kubernetes distribution of those IP addresses, just to make sure that the customer get the right service. So here we set it to true. And now we can apply the changes. So I just got from the kubeproxy YAML file, and after I just changed that parameter and I applied it, so now it's set to true. So this is very important to do in order for MetalLB to work in your local cluster. Okay, let's just make some verifications. We're going to describe the config map of kubeproxy in the namespace kube system. Good, and here we can see now it's set to true. Strict ARP IPVs. So we're going to install MetalLB. This is from the documentation. We install it straight away from the repository. kubectl apply f, and we put the address of it. And after we can check what is deployed in details. Just stop a bit. So just let's get all. In the namespace MetalLB system. So it's still deploying. So the containers are still creating. Service webhook, daemon set, the speakers that we've seen in the architecture, the controller, which is going to be deployed in one of the workers. I'll do it again, it should be fine. Yes, I put all white so we can see also the different addresses. So it is still creating, but we have the daemon sets, the pods This one is in worker 1, which is the controller. And we have the pods in every single node. We have the daemon set is 3 speakers. So that's the pod that you see on the top here. And the deployment. Just to see where everything is placed. So it's going to take a few seconds to deploy, and after that we'll be able to go to the next part. Just going to describe. What can you describe? We're just going to check one of the pods where it is in the steps of deployment. I'm going to put the name of the pod. Okay. So pulling the image. That's where we are at. The volume, failed, volume member secrets. It will retry and succeed, but you can get this kind of error sometimes. We can check the secrets if they're present or not. Get secrets. Yes, so you see we got the member list secret. So when he's going to retry now, he will be able to find it. As you can see, it has an age of 3 minutes. Now it's okay. Container created, started. Okay, so now they will be able to start one by one. Let's check this one. This one also has started. So you should have them all. Yes. So now the infrastructure is ready. We got all the components deployed, MetalLB. Good, so we got everything deployed. After, for the deployments that we're going to use the ones that we used in the previous video. We're going to create first an IP address pool. So those are the steps that you need to follow. You remember inside the controller, there were IP address pool, so we're going to create that. It can be IP range, it can be IPv4, IPv6. So these different ways to define those IPs. This is coming from the documentation, but we are going to customize it. Okay, so at least you've seen it once. We're not going to use IPv6. So this is the IP ranges example. For the moment, I'm just going to comment it out and simulate the fact that we're going to use the first one. But I'll be showing you later on how to customize it. So CIDRs, you can also use CIDRs if you want to use subnets. So set service deployment. So the services deployment to load balancer. We have to change the type because the services they are in cluster IP. That's their default type, which is just internal to the cluster. But now we want to expose the applications which are behind these services. So as you can see here, I'm using the same template that we used in the previous video. So it will be less confusing and you'll be able to follow up on that. And here we change the type also to load balancer. And after we need to add the MetalLB annotations to the services. So and here we have the L2 advertisement. This is in the controller. We have 2 of those. So now we can customize a little bit the IP address pool. You can pause the video if you want to see those parts. So I'm just gonna put here an address. So after I'll be coming back in those files, so you'll be able to see it, to see how it is organized. So the annotation here, it's for the load balancer IP. So here we're gonna set a fixed IP. An IP that we have decided it's going to be this one for this load balancer, for this service. And in the other one, we're going to just take the name of an IP pool, IP address pool, and we are going to see how Metal load balancer is going to affect the IP. So it's going to see out of his range of CIDR and give an address to this service. So I just moved the annotation because I figured out that it was in the config map, but it should be here. It should be in the service. You see, this part is the service. So we can set this to target on address pool. So get an IP from the range, set there. So here I'm just going to change this, which is from the documentation. And we're going to use a custom IP address pool that we have created called the red pool. And here is the details of the customization. So we have here an IP range that we have chosen. And the annotation is going to be referencing that IP range, which is the red pool. That's the name of it. So red pool here, set to, I'm just going to copy what we got in the other side. So that's the IP range. So we should get an IP between ending 240 to 243. And in the other service, we're going to get a fixed IP because we have decided to have just one fixed IP. Now we're going to just apply that to the cluster. So those configurations, that's for the IP address pool. And after the L2 advertisement. The L2 advertisement is going to check the IP address pool and check the service in the other side and provide the right address to it. And the end user will be able to access applications using that address. So kubectl apply f, do we need to apply? Yes, the config files. So we're going to just get 2 of those. One is displaying the message in red, the other one in blue. So the Nginx one is deployed, but here there's an error. We're just going to check what is the error. Nginx 2. This is okay. Load balancer. So that's the Nginx 1. Yes, the service Nginx 1 is invalid. So just gonna try again, but only Nginx 1. Now it's okay. I might have done a typo error. So the namespace. Do I need to change the namespace? No. Let's just get those services. So it's not load balancer. It's services in the default namespace. So we got these two services. So you see, they got an external IP. One is the fixed one, 251 at the end, and the other one 240, which is coming from the IP pool, IP RAID pool, which was between 240 and 243. And we got it, and here we can see 240 on the top, 192, 168, 1240. We got the RAID service resolved. And in this one, the one that we decided to be a fixed one. So the fixed one exists and is dissolved. So we got the service resolved. Why? Because Metal load balancer is going to check and see that we have. So here I'm just changing the messages quickly because it's not a gateway API, it's MetalLB. Yes, so it's going to recognize that this address is available in the other pool. So 192, 168, 12, 251. You can see in the second pool down there, the blue one, it exists. So because there's a pool with this address available, it could provide this address to the Nginx 2 service. While in the other one, the IP range is already defined. So we provided just the name and we got the IP address. Just to show you two different ways to get those addresses, and this is the L2 advertisement where we reference those IP pools. You see the blue pool and the red pool here, the names, they're referenced in the spec section. So now we just open this, we have the config map. We have changed the message. We have the service, Nginx 1. And here we got the red pool. So here we just gave the name. That's why I do this recap, because it can be a bit confusing. The L2 advertisement recognizes the red pool. And after it goes to get an address from the IP pool, red pool. And after it finds the IP range, and it's gonna be giving an IP range to Nginx 1, which is 240. So that's the workflow. That's how it goes from the service to the user. So same here for the other one. For the other one, Nginx 2, we set an IP address 250, ending with 251. Okay. So the L2 advertisement is going to check in the IP pools. It's going to see that we have this IP range available here in the blue pool. And after, same as the one before, we'll be able to get this address. So 240 and 251. So wrong IP address simulation. Let's try to use an address that is not part of the IP pools and see what's the behavior of MetalLB and the Kubernetes cluster. So we're going to apply these changes. We're going to check if the services are displaying this is still 251. So I might need to delete this one and to reapply, because this is the previous one that we had. So let's delete this. service and do another deployment. Okay, so we have only one service. Now so 251 you see it's buffering, so it's not able to resolve. That's normal, we have deleted it. Let's use the command that we used before. Here, Nginx 2, so now we get the service back, but you see the status, it's pending. Why? Because there's no IP pool created. So that's why it doesn't work. So that's the behavior of MetalLB on the cluster, because there's no address. We have between 250 and 253, and here between 240 and 243. So we've set, I believe, we've set 254, I think. Yes, 264, which is not part of the IP ranges available. So nothing is going to be, there won't be any external IP address, so no external IP address for this service. Let's put it back to 52, for example. This is part of the range. Let's deploy it again. And now we got it back. See? Instantly. So now we just change the address to 52. And we will be able to resolve. I might need to use maybe the private mode. Here it's still... let's wait a few seconds. Nginx 2, I just check. Announcing worker 2 after 39 seconds. Yes, there were 80 seconds of difference between the IP allocated and the allocation failed. Okay, let's maybe go back to the browser. Here everything is fine. Nginx 1 is okay. Let's check that brief also. So we got our 3 speakers. And we got the address. So it should be okay, because now the pod has the address. Let's go back and check. Maybe it needed just a few seconds. Close this. We get it again. Should be fine. Yes, it's fine. So it needed just a few seconds. Let's have our first break, or unique break actually, just to give you the time, because you were waiting to like and subscribe as usual and share. So one IP address equal to one service? No. So the case of one IP address shared between multiple services. So we're going to change the annotations here to provide the option for services to share IP address, the same one. So here, this one I might, no, I keep it. red pool, comment it out. Okay, so here we have an IP address that you have set. You put the annotation. Let's redeploy the services. So the other one is pending because I haven't set it properly yet. So I'm going to change the ports. There's some conditions for it to work. Is that the services have different ports or different protocols. There might be something missing. I believe that's the type load balancer. You might need also to... so the red pool, okay, the red pool first, because this address is part of the red pool. Let me just comment this. So you might have a bigger infrastructure. You can't have one address per service, because you might be limited in the number of addresses available. So you might need to have one address serving different applications behind. But those applications, they all use different ports, presenting different ports to that L2 advertisement. So at this time, you'll be able to serve different services using the same IP address. So you're going to save your IP addresses. So this annotation for sharing same load balancer IP for different services. Port must be different or the protocol. So TCP, UDP, and so on. And the value of this annotation must be the same. So in the other service that is sharing the same IP address, you need to have the same annotation on the same IP address, because it's going to be the one determining that they're sharing the same IP address. So here I'm just going to put a name for it. Let's call it red, blue, sharing, same load balancer IP. Let's get rid of those lines. Now we have the same. So we choose to define the pool, red pool, and after we did add the annotation allow shared IP, we called it red, blue, sharing same load balancer, and after here in the spec we need to add the load balancer IP. So I took this from the documentation to be set when sharing same load balancer IP. That's what I was missing actually with other services, but protocol or port should be different in the other service. Also, we need to add a name and the protocol. So let's put the name and the protocol. Protocol HTTP. Let's give it a name, HTTP red. Name and protocol should be added when using shared load balancer. Otherwise, we don't need it. So we got that part on the load balancer IP. Might need to change this IP address. Just going to do the same in the other service. Okay, almost there. HTTP blue, just to say it's the blue one, even if they're sharing the same address, they have different ports. Now what we can do is have an IP address matching our settings, not the one from the documentation. So 192.168.12.242, because the red pool is from 240 to 243. Okay, so we do the same here, and they will be able to share this IP address. Okay. MetalLB blue. There were an error with the protocol. It's TCP, it's not HTTP. So protocol, UDP, TCP, it has to be, but not HTTP. That's good. So now we got our deployment. So let's see if we can resolve those services. You see here they got the same IP, external. So I use the private mode just to make sure that I have no cache from the previous ones that we did, previous pages that we showed. So 252 doesn't work. There's no 252. That's normal. And after 240, it needs a few seconds as before. I don't know why, but yeah, 242. It's not 240, it's 242. So we get the blue one. So the blue one on port 80, that's this one. And the container port is 80 also. The target port has to be the same as the container port. So this is good. So that's why this one works. Let's see the other one. So the other one was on port 81, but it's not found. Why that? 82, found 82 doesn't exist, we didn't set, but we've set here, you see 81. So it's good to see those little issues so that you understand how you can fix it. So before I fix it, will you be able to find it? You can see it here normally, but I'm not gonna make you wait for that. Let's just go straight and fix this one. Right, look at your time. So here we got 80 and 80. This is the model, the one which works. Now let's go to the other one. This one, target port, the port is 81, is good. It's a different port from the other one, so they will be able to share the same service. But the target ports behind, or the container, should be 80, because Nginx, it's by default served on port 80. Otherwise, you get the 404 page, and you won't be able to see it. So now we just need to deploy it again. .42, that's the blue. If we do the port 81, now we got it. Okay, so the recap can be a bit confusing, so I'll just do a recap of what we've seen. IP address pool, the red pool has a range from 40 to 43. The blue pool has a range defined from 250 to 253. You can also use CIDRs if you want to do subnets, or IPv6 if you need to also. With IPv6, you don't have the problem of sharing IPs between the services. You can just provide the one IP per service. After we have the L2 advertisement, which is going to reference the IP pools, the red pool here, and the blue pool. So you need those, they're in the controller. So you can get IP address affected to the right service. L2 advertisement, so that's the name of it. It's a red-blue address pool advertisement. After that, when you start, before the installation, just make sure that you have the IPVs here, the strict ARP parameter set to true. So address resolution protocol. So to make sure that the load balancer can resolve to the right IP address, to the right service, and the right port, and so on. So it's going to make Kubernetes more efficient in doing that. That's what we've seen before here. We can also check the config file, how it is linked to it. Okay, so we got our config map. This is just to change the page of Nginx. And let's do here the right pool, for example. When we used it, we just put the name using the annotations. So here, just use annotations to define which kind of pool you want to choose, or you can also define the fixed address if you want to. Okay, so this is the shared one, allow shared, that one we did before, but there are conditions. The protocol or the ports must be different. Okay, port must be different or protocol. And the value of this annotation has to be the same as the other one. So the name of it, you see it's a random name, that's why I wrote it like that, so you know that this name, you decide what it is. The type load balancer here, you need to set the service to type load balancer. If you want to do a sharing load balancing, you just choose your pool here. You know the range, so you put the right address in the load balancer IP. So the red pool, That's the one we advertise. That's how it is linked to it. After the red pool, and the load balancer will be able to be affected here to have one address out of this address range. It's a TCP protocol. This is the port that has to be different, and the target port is going to just target the service. Alright, I hope that you liked this video, and see you next time.